Welcome to Intel on AI, the podcast that connects listeners with leaders. My name is Heather McGuigan, and I am your host. Today's guest is Peter Shen. Peter is the head of Digital and Automation North America at Siemens Healthineers. Peter's passion lies in building bridges between innovation and real-world healthcare needs, using groundbreaking technologies like AI, data analytics, and 3D visualization. He has been a keynote, public speaker, and industry expert for 25 years across the globe, and testified before U.S. Congress on AI's potential to reshape healthcare. Peter Shen, welcome to Intel on AI.
Thanks so much, Heather. Super excited to be here today.
Now, we have a great 30-minute chat about how we are bringing AI into the healthcare system. Are you ready to get started?
Let's do it.
Amazing. So you've been at the forefront of healthcare digitalization for 25 years. What excites you most about AI's impact on healthcare today?
I think what's super exciting about artificial intelligence in healthcare is that we've got now this amazing technology that's constantly evolving. And here's this great opportunity to take this technology, which you and I are getting more and more comfortable with in our daily lives, in our personal lives here, and now trying to figure out how can we take this evolving technology and apply it to a space where we need some of this help, actually, which is in healthcare, where healthcare today, we've got numerous challenges. You know, some of the biggest challenges that we have in healthcare right now is that there's a tremendous shortage of resources, everything from nurses to clinicians to anyone that's really helping the healthcare environment right now. We have a staff shortage issue right now. And here's a technology like artificial intelligence could actually help impact and help us with that particular challenge. There's also the big challenge within healthcare of more and more patients actually needing healthcare. We have an aging population, and that aging population continues to grow, but we don't have the resources really to take care of all those of that aging population that's requiring more and more healthcare services. Again, another great example where we could actually utilize an emerging technology like AI to be able to help us here. So lots of great opportunities for artificial intelligence within healthcare, and to me, that's what makes it really exciting. Is how can we take this technology that's constantly evolving, that some people might think is complex or whatnot, but really try to take that technology and try to apply it to something practical and something that we need, which is some help within the healthcare space.
Amazing. Now, one of the first things that a patient needing care experiences is the diagnostic and treatment planning phase. So what are some real-world examples of how AI is improving patient outcomes when it comes to diagnostics and planning?
Yeah, you're absolutely right, Heather. So again, anytime we're not feeling well or something's not right, the first thing that we do is always get some sort of diagnostic test. And in many cases, it's like, especially if someone's hurt or injured, it might be like a CAT scan or an MRI scan or anything of that sort. And I think what a lot of folks don't realize, a lot of patients don't even realize, is that a technology like AI is actually already impacting their healthcare experience today. So for a great example is if let's say I need to go get an MRI of my knee because I hurt it or whatnot, if I go to like that MRI and get that MRI exam, when I lay down on that MRI on that table that's connected to that MRI device, the MRI machine from Siemens Healthineers, for example, it has a camera that's built into that MRI. And that camera is actually looking at my body and recognizes the anatomical structure of my knee. And the reason why it's doing that is that we took the exact same AI algorithms that you and I are used to in our personal lives that say, when I take a picture, it says, oh, this is a picture of a dog, or this is a picture of Peter, or anything of that sort. And we said, hey, instead of having the computer recognize that this is a dog or this is Peter, why don't we train it to recognize that this is a knee? And so what we did was we created algorithms that looked at different parts of anatomy and recognized those different parts of the anatomy. And we use that in that MRI so that we can then position that patient and that patient's knee in the exact precise position that we can get the best images of that knee to look for where that problem is or where that pain is on that knee. So just positioning the patient in these diagnostic devices, we're using tools like artificial intelligence to be able to make sure that we get the best image possible coming out of that MRI or that CT device, but also that also speeds up the entire diagnostic exam. So instead of waiting seconds or minutes to try to position that particular patient on that MRI device, I can use AI and computers to be able to automatically position that patient in that MRI device and essentially speed up the actual imaging exam itself. And so patients actually get to go in and get out of there a lot faster, and then they get even better images of their knee to figure out what the problem is. So that's just a simple example of how AI is already impacting patients and their experience when they're encountering a healthcare diagnostic exam.
Amazing. Now, Siemens Healthineers focuses on multimodal AI. So we know that we want to be pulling in data from all of these different places. We don't just want data from the one hospital that you go to. So how does this approach enhance clinical decision making?
Yeah, it's a real important aspect, Heather, because again, if I'm trying to diagnose what's something wrong with a patient, or if I'm trying to figure out what's the best treatment for that patient, I can't just look at their MRI of their knee. I also need to know other pieces of information about that patient. So it would be great to kind of understand maybe the patient's history. It would be great to also understand maybe, what are their laboratory results? Maybe they had a biopsy. So what are the pathology results? Maybe they had all these other tests that are happening there. And so the opportunity to get all those different pieces of clinical data together and then overlay all that data with a technology like artificial intelligence to find correlations within all those different pieces of data is actually a way that could help clinicians make a more informed diagnostic decision, or maybe even a more personalized treatment decision for that patient, because I have now kind of all those additional pieces of clinical information about that patient themselves. So this is where we see tremendous potential for technology like artificial intelligence, is the ability to aggregate and bring in all this relevant clinical data about the patient, personalize it, and then be able to have that more informed diagnostic or personalized treatment decision for that patient.
And it's something I've never thought before in terms of comparative analysis of a body in regards to a certain activity. So you wonder and go, okay, the sort of bone structure of, say, a football player might be very different than the overall bone structure of a ballet dancer. So when we start to sort of gather that same data, you can go, well, ballet dancers' bodies do this. So here's where we can see a ton of data that connects ourselves together. And that allows to go, no, this turnout or this type of muscle structure or this break is common within this type of sport. Here's how we can improve it or how we can look at prevention in the future.
Yeah, this is why topics like precision medicine are so important here. So we have to understand, as you well articulated, Heather, that, there are different, everyone's anatomical structure is slightly different, but then also the way that they're utilizing their body and how kind of, maybe abnormalities evolve from all of that. These all have to be considered. And this is why it's so important to have diagnostic tools, technology tools like AI to kind of look at kind of precision medicine here to really understand specifically from a personalized standpoint, what is maybe the effect from a diagnosis standpoint, and then what is the proper treatment for those particular patients, those individual patients themselves as well.
Amazing. I want to talk a little bit about AI at the edge, which is a growing trend in healthcare. What role does it play in three spaces: in imaging, in diagnostics, and in personal treatment?
The edge is such a critical component to the evolution of of technology, and in particular AI within healthcare. So if you think about it, we just talked about kind of all this data that's being generated here. I need to be able to compute and process that data as quickly as possible. And in many cases, especially in the healthcare space, I mean, there's potentially, dire consequences here. Yeah, there's potentially life or death situations, and decisions, clinical decisions that have to be made rather quickly here. So the ability to compute and process all that data at the edge versus trying to move all this large amounts of data from one place to the other to be processed, that becomes very, very critical. So from an imaging perspective, I can tell you as a great example is that we go back to those MRIs that we were talking about earlier. These imaging devices produce a tremendous amount of data. And some of the data results in these images that we're talking about here, but just even the data that is generated that has to be compiled to create those images is a significant amount. And so the need to be able to process that nearly real time. And if you think about it from an imaging standpoint, take like, for example, like the heart as a great example. So this here you have this organ that is in motion constantly, right? So now if I want to take a really good picture of that heart that's in motion constantly, I've got to be pretty quick about it, right? And I've got to be able to kind of process that image as quickly as possible. So this is where edge computing becomes tremendously helpful here, is the fact that I can take kind of this piece of anatomy, this anatomical structure that's in motion, be able to take a snapshot in time of that, process that nearly real time, and give that output then to that clinician so that he or she can make that decision. That's only really possible if I can do that computing at the edge rather than trying to move all this snapshot data from the MRI device to another location to be processed and then move it back to that clinician so that he or she can visualize that. That's the key component to why the edge computing is so critical from an imaging standpoint. So now take that a step further. Now I'm trying to make a diagnosis here. Again, as we talked about earlier, sometimes these diagnoses are mission critical. I've got to make that decision sooner than later here. Yeah, especially if we have a trauma patient that's coming through the ER, for example, that we've got to make a quick decision on what's the next care pathway for that individual patient here. Again, this is where I've got to have edge computing readily available to me in terms of making that diagnosis. And then finally, as we talked about earlier, kind of, if I want to really drive personalized medicine here, precision medicine, personalized medicine, by combining all these different pieces of clinical data together, again, it's the challenge of now I've got to aggregate all this data, and am I going to move all this data from one place to the other to get it processed and then move it back to the clinician so he or she has to see it? No, I actually want to do that right in front of that clinician so he or she could kind of make that diagnostic or therapeutic decision for that patient. We want to do that closer to the patient. The incredible part about where we are today is that compute power is getting faster and faster, and that also means we can bring it closer and closer to the patient themselves. And this is why, again, computing at the edge is so critical for us from a healthcare perspective.
And in terms of the patient's experience, when that data can come in faster, it means a knowledge of what's happening faster, a relief of anxiety that you're not waiting days and weeks to sort of find out what's going on. You're right in a place where that information comes back, and then you have the ability to make a decision that is free from the anxiety or the weight around that process.
This is a tremendous benefit here, Heather, and a great practical example of that is when you think about screening exams. So if you think about females that are coming in and getting, a screening mammography, patients coming in and getting a screen for lung cancer or whatnot. So they're getting these screening exams, not knowing what the outcome is. And so they get these, they get their mammography mammogram, they get their, maybe their diagnostic chest CT exam or whatnot, and now they wait. And now they have to wait. And now if we're saying, okay, well, we've got all these images, we've got this data, and now we've got to send it somewhere so it gets processed, and it's going to take a little while, and then we'll come back and let you know what's happening with you. That's terrible for the patient, actually.
Anxiety that you didn't even need to know you have now just by waiting.
That's exactly right. So instead, can we do that mammogram? Can we do that screening chest CT exam? Can we immediately then utilize, edge computing and the ability of these AI algorithms here to spot abnormalities, to be able to or even look at the exams and say, hey there, I don't see anything bad here, so that we can immediately tell these patients, like, look, you're everything's good. The screen, no problems. Or if there is something that's abnormal, we can immediately get those patients into the right care pathway to take care of them. This is why, again, being able to process all this data as quickly as possible, so critical for us in the healthcare space here.
You recently spoke at CES about AI's impact in healthcare. What were some of the key takeaways from that discussion?
Yeah, I think it was very interesting. I think, from at CES, and where, a lot of folks are really curious on how healthcare is being impacted by these kind of evolving technologies like artificial intelligence. I think it's clear, AI has some really great, positive things that are helping healthcare in terms of like what we talked about in terms of driving efficiencies within healthcare, but then also help assisting with diagnosis and therapy or whatnot. A lot of the discussion that we had in CES is then now how, if we all acknowledge that this technology is amazing and has great impact, what do we need to do to help drive the adoption of this technology in the healthcare space? What are the hurdles that we need to overcome to make sure that physicians, clinicians have access to this wonderful technology, that patients actually get the benefit of this type of technology? And these are some of the challenges that are currently facing healthcare right now as it relates to AI, is that within the industry, we see this tremendously impactful technology. But now, how do you integrate that technology into the routine clinical workflow that a physician has? So the way that they go about taking care of their patients, the way that they're doing their diagnostic exams or doing their therapeutic procedures, how do you now inject this technology into that process so it isn't disruptive, it doesn't change the way that they're necessarily practicing medicine, but instead actually helps support kind of the clinical decisions that they're making for their patient? And this is really where a lot of the focus of organizations like ourselves at Siemens Healthineers and others within the industry are really looking at right now, is like, how do you actually integrate this technology into that routine clinical workflow?
I wanted to ask a little bit about AI-enabled medical devices. Now, the number of FDA-cleared devices has been rising. What opportunities and challenges come with regulatory approval in this space?
Yeah, I think you're absolutely right, Heather, that I think now it's close to, or actually it's over 1,000 different AI algorithms have been approved by the FDA as medical devices here. So certainly I think it's a strong acknowledgement that AI is having an impact within healthcare here. Now, I think that regulatory process is an important process here, because I think as much as there's concern about, AI and its impact, and is it hallucinating and creating different kind of, incorrect diagnoses and all this other stuff. I think that having a regulatory process, and in particular, an established regulatory process like the FDA that acknowledges that these different algorithms have gone through kind of the requirements needed to be able to use on patients is a real critical one. And for us at Siemens Healthineers and our participants in the medtech industry, we see this as an important aspect that we need to maintain kind of this level of regulation around this type of technology to make sure that it is safe for patients to utilize. Now, at the same time, I think where there's some challenges is that it goes back to this adoption topic. And what's interesting is that even though there are over 1,000 different AI algorithms that have been FDA cleared, from an actual reimbursement standpoint. So if I utilize this technology, will I get any sort of reimbursement coming from the payers for utilizing this technology? What's very surprising is out of those 1,000 or so algorithms, really less than 30 of them are actually getting any sort of reimbursement associated with that. Now, why is that important? Because reimbursement potentially can drive the overall adoption of these technologies. So if you think about it from a healthcare provider standpoint, if I see this wonderful technology that's making this tremendous impact in this space here, and I would obviously love to utilize that technology and invest in that technology, the challenge I have as a provider is that I don't have with great certainty any guidance on whether that if I use that technology, I'll get any sort of reimbursement for it. Or I might just get the same reimbursement as if I didn't use the technology itself. So the challenge becomes from a provider perspective is that, should I make the investment in a technology like AI, not knowing whether I'll get reimbursed for spending the extra money for that, or should I just continue to do everything that I do right now and not worry about that? And so that's what's really holding back healthcare from truly adopting this technology is the uncertainty around getting any sort of reimbursement or acknowledgement of utilizing this groundbreaking technology. And so that's the big advocacy that we're doing here at Siemens Healthineers is really trying to encourage folks that are setting policies and things like reimbursement on really trying to help incentivize healthcare systems to adopt this technology. And by adopting that technology, that will actually then make that technology more accessible to patients, especially in kind of the rural and underserved populations.
Yeah, that sort of leads into my next question. And I wanted to talk about the opportunity to reduce costs and optimize workflows by using AI. Is that we have these amazing technology, these great devices, but we need to integrate them into a system that may not be ready yet, or that doesn't have the technical abilities yet. Are there ways to use other versions of technology of AI that can help reduce costs to optimize workflows that can possibly free up some of the budget in order to use some of these ever more advancing technologies?
Yeah, absolutely, Heather. I think it's a very complex space here, trying to figure out how do I make an investment in this technology type of thing. And that, I think that's where here at Siemens Healthineers, one of the things we're very focused on is, rather than trying to look at AI as kind of this standalone technology, it doesn't make more sense to actually integrate these wonderful advances into kind of like the diagnostic devices that we have, right? So integrate AI technologies into that MRI scanner, into that CT scanner, into that ultrasound device that we have. So a great example is that that we're seeing some tremendous benefit on right now is that folks that are doing kind of ultrasound examinations. So if they're doing an ultrasound exam, as many of your listeners are familiar with, they'll use a probe to kind of look for certain anatomical structures. Once they find it, they actually then have to make some sort of measurement around that. And because it's kind of involves kind of a human kind of moving this like ultrasound probe around, as you can expect, sometimes it's challenging to find the right anatomical structures. Sometimes it might take longer. The patient might be moving, all these type of things here. So here's a great opportunity to interject kind of a technology like AI to help us with that. So if I can embed AI into that ultrasound device and the same kind of technologies we talked about earlier in terms of recognizing my knee when I'm laying on that MRI device, I can actually create algorithms that when I move that ultrasound probe, it automatically recognizes, oh, this is the abdomen. And once it senses where that abdomen is, it will quickly, because of edge computing, be able to quickly make that measurement of that abdomen while that probe might still be moving by that sonographer doing the exam here. So actually embedding the AI technology into the to the imaging devices themselves, the diagnostic devices themselves, leveraging the compute power that's available there next to the patient to be able to quantify, in this case, anatomical structures, that actually speeds up the exam, right? So if I can actually quickly make the measurement on that abdomen, I can move on to the next thing that I need to do and actually can reduce the overall time it takes to do that exam. That in turn then allows me maybe to see more patients because we've got lots of patients who need these services or whatnot. There's greater patient satisfaction because they don't have to spend so much time getting these type of spending this time kind of waiting for these exams to be done. So there's tremendous benefit, and it all starts by, again, integrating the technology right there and there next to the patient themselves.
Absolutely. It feels remarkably personal as you described that story. When I was carrying my son, I had an ultrasound appointment that took 3 hours because he was faced away from the camera and wouldn't turn forwards. And so they had to keep like moving me around, and we were trying to hang upside down, and we were trying to roll over on different sides. And then I had to wait for an hour, and they were like, can you go drink something cold? Can we do something to like get him to move so that we can see? And they said, our camera just will only take this from one angle. We can only pick this up from one place. So it was the appointment that should have been 20 minutes was 3 hours. And that difference could have been 6 more women who get to have their ultrasound in time.
6 more women or you being able to go home and do other things, and also reassured that, everything is okay versus having to endure 3 hours of like, oh, what's going on? That type of stuff.
Yes, there's something wrong that they need to see. Like, again, you build anxiety you don't even need to have.
Exactly. And again, this is where a great example where we can take the technology and integrate it into that exam itself, right? So instead of talking about AI as this whole separate type of technology that's impacting healthcare, it's actually taking AI and actually integrating it into again this routine ultrasound exam. And this is where we see tremendous opportunity to gain some great benefits both operationally and clinically for healthcare.
I wanted to ask you a little bit about your, I guess, appearance at Congress. I don't know whether it's sort of a performance. It's an appearance is the discussion. As you talked about AI's role in healthcare, the first question I wanted to ask is, did that opportunity to speak feel different than any of the other major global conferences that you have spoken at?
Certainly, I think with all the attention around an opportunity to speak to our lawmakers, it feels a little bit of a different environment or a different stage. But I think that the discussion and the questions coming from our lawmakers are the same ones that you and I have as it relates to AI. Really, how is the AI working? How is the AI making these different determinations? What are creators like Siemens Healthineers doing to ensure that these AI algorithms that are created, how do we make sure that they actually are doing the right thing, that they're reflective of the patient populations that they're going to be applied towards? So I think it's similar questions that I think we all have here. So it ended up being a very much an educational type of discussion, really trying to understand, here's how we create these AI algorithms. Here's how we apply them. Here's how we make sure that clinicians and patients are comfortable with these different AI solutions. This is kind of all part of our on the discussion that we had there. So, and then I think similar to what we talked about before, we really tried to encourage our lawmakers to help us foster adoption of this technology. So we clearly see the positive impacts of AI to patients here. So now what can we do to help make sure that clinicians and health systems adopt this technology? And this goes back to our conversation that we had earlier about, is there a way to make sure that there's proper reimbursement, consistent and predictable reimbursement around this technology so that healthcare systems aren't apprehensive to make the investment in this type of technology? These are some of the things that we encouraged our lawmakers to look at with something evolving like AI.
Just like way more cameras and microphones.
A few more cameras. Sure.
A lot of flashes. You kind of felt like a movie star a little bit.
Just for a few minutes. Yeah. So.
I want to ask about data interoperability. I had to practice that word a couple of times. I won't lie. I had to go interoperability. I had to sort of figure my way around that one. It's a tricky word to say and a tricky topic to take on. So I would imagine that hospitals are trying to figure out, how do we get data from here and here and here and here and here, and how do we make it all come together and work? How is Siemens Healthineers addressing the challenge with AI-driven solutions?
It's a great question, Heather, because you've really hit the nail on the head on what's really driving this AI revolution. And it's really all about the data. And how do you make sure that data is accessible? How can you exchange that data? We talked about kind of the patient's history and all the different clinical things that happens to the patient. And it would be great to kind of pull all that data together. But you have to have this interoperability to be able to do that. And so one of the cornerstones here at Siemens Healthineers is that the different AI algorithms that we develop here, we make sure that those solutions are utilizing the different data standards that are established right now within our industry. And then we also make sure that they're compatible, not just with our own devices coming from Siemens Healthineers, but also from non-Siemens devices as well. So making sure that we have the ability to have access and transparency to that data, whether it's coming from a Siemens Healthineers device or coming from a different device. And then making sure the outputs of these different AI algorithms are compatible with the different IT systems that are out there as well. So again, following the standards that are out there established by our industry, but more importantly, making sure that we have the integration capabilities to be able to connect our solutions with maybe other IT or other clinical solutions that the health system has.
This has been an absolutely fascinating conversation. I have one more question to ask, and I have like 10 more, but right now I'm going to see if we can sort of summon what we have been coming to as part of this discussion today. I want to paint a picture of a hospital in the future that is fully powered by AI. So what is the perfect patient experience that comes out of such a hospital?
Yeah, I think, Heather, we can think of the future of AI and healthcare in a couple of different ways. The first is like what we talked about earlier. If I have the ability here now to bring together multiple pieces of clinical data about the patient, so those MRIs and CTs that I had on the patient, the laboratory results from the patient, the pathology results that are there, the genomic results and genomic history of that particular patient. If I can bring all those things together, have AI on top of all that data to find correlations within all that data, I can actually start to make that more personalized kind of treatment for that individual patient. Now, if you think about it, if I have all those different pieces of data, I could actually start to create what I would call a digital twin of that patient, right? So if I knew kind of what, this is a picture of the patient's heart, and this is all the clinical information about, the blood that goes through the heart, the physiology around it, the biomechanics around it, all those different types of things. I can actually start to create maybe this like replica or this twin of this patient's heart. And why is that important? Because now if I have this digital twin of this patient's heart, now if I need to treat that heart because that heart maybe has some sort of abnormality like an arrhythmia, a tachycardia, or something of that sort, instead of now trying to guess, hey, what's the best treatment for this patient, and then giving that treatment to the patient and seeing what happens, I could actually now try that treatment on my digital twin of the heart. So I could try the medicine on this digital twin of the heart in this kind of simulation, if you will. See how successful or unsuccessful that treatment is. Maybe I've got to change the dosage. Maybe I've got to, change the way that I'm, injecting the medicine to the heart or something of that sort. But I can actually optimize or find the optimal treatment for that individual patient there. And I could do that all in my digital twin. And once I figure out what that optimal treatment is for the patient, then I can actually go to the patient themselves and actually administer that optimal treatment that hopefully will lead to a higher rate of success in terms of curing that ailment that patient has. So you think about the possibilities here with artificial intelligence to actually create kind of this digital twin of the patient, where it could actually test certain therapies on that digital twin to find that optimal therapy, and then administer that optimal therapy in the real world to the patient themselves. And that would be ideal. Yeah. Now, if you think about it though, if I can do all that, why are we even talking about how do I treat patients? Why don't I actually, go back to the beginning and say, hey, can I, with the digital twin, can I actually look at preventative care? So if I have this digital twin of the patient, and let's see now, if I tell the patient, hey, maybe you should exercise more, maybe you should change your diet, you should do all these different things. Now, maybe could I actually prevent that abnormality in that patient's heart? Could I prevent that arrhythmia or tachycardia? If they actually did something different with that digital twin, I could actually start to almost create an experiment and try to figure out what are those things that I could change about that patient's lifestyle, diet, this or that could actually then have and see them what that effect is. And I could then give that optimal advice to that patient from a preventative care standpoint and actually drive wellness for the patient. So these are really exciting opportunities here that we at Siemens Healthineers believe a technology like AI completely enables, especially the concept of a digital twin here to promote, again, optimal treatments, but ideally kind of promote overall wellness for the patient going forward.
That is a concept that I'm going to think about all night, about how that can get integrated, how someone go, hey, I'm seeing this down the pike for you. I'm seeing this heading this way, or thousands and thousands of pieces of data are predicting that this is where this is going to happen. To these steps, and taking these steps is going to reduce things, which means I don't have to see you again, which I think is always what we want in healthcare facilities, and to go and never return. I want to thank you so much for coming on the show today. This was such a fascinating episode. For those who would like to find Peter Shen on LinkedIn, there are a ton of very, very cool articles to listen to. You can watch a little bit of the speech from Congress. Thank you so much for joining us.
Yeah, appreciate it, Heather. Thanks so much.
And thank you to all of our listeners. This is Intel on AI. My name is Heather McGuigan. Thank you for watching.
Visit intel.com/AI to learn more.